Welcome to video number 65 on A-level computing, and in this video we're going to look at programming and subroutines. So, subroutines. These are used everywhere in programming. They're sometimes used to tidy up code into different sections to keep things neat and tidy, but more often they're used to reuse code to be efficient and to allow for the easy maintenance of code and not to reinvent the wheel every time we want to do something. There are two types of subroutine. There's procedures and there are functions. If we want to define subroutines, we'd say subroutines are blocks of code containing instructions to be executed. Subroutines are given identifiers, and that is the name of a subroutine. The identifier is used to call, and when we say call we mean execute the instructions within the subroutine, and it's called from the main code. First of all, we'll look at procedures. So what I've got here is a tiny little VB.NET program with 3 text boxes and a button on there, and if I look at my code for the button, which is called cmd save, what's happening in this code is that the 3 text boxes and the button are all becoming disabled, which is something you'd often want to do if you were performing a save operation, that the buttons would disable. Let's just see that happen. So that the user can't do things to data or try and save again whilst the save is in operation. That's why that happens. So those 4 bits of code there, we might want to disable those controls at other times, not just when we click on the save button. So what I could do is go and cut that code and write myself a procedure and paste those 4 lines in there so it becomes more reusable. So I'd declare a procedure which is done like this in VB.NET, and I might call it disable controls. Hit enter and it gives me my end procedure syntax, which in VB.NET is end sub, and then I'm just going to paste in my 4 commands there. Then when I want to call the identifier for the procedure, I just type disable controls there, and if we put a breakpoint on, we'll be able to see what happens here now. The form runs, click on save, the code stops here, and what it's going to do, if I F8 in this version of VB.NET, is it jumps down, it calls the procedure called disable controls, and I just step through it there, and then the code returns to the main program up here. So it does the same job, but the beauty of it is I can reuse these 4 commands just by calling disable controls at any time, which I may well want to do. I might have another button on my form which I need to do that, or another instance of it doesn't have to be a button, it could be when we lose focus from a text box or something. So we've made some reusable code there. So now we've seen a procedure working, here is a definition. The main program will call a procedure by using the procedure identifier in a line of code. When that line of code is executed, the main program pauses whilst control is passed to the procedure. When the procedure finishes, control returns to the main program and the rest of the main program is executed. So here's our main program, which, as we saw from the VB.NET example, the main program itself will probably be a procedure. If I just remind you of what I mean by that. The actual command save main program, as we can see, uses the same syntax as our procedure. So it's actually a procedure itself, but it calls another procedure. So that's what I'm going to show you in this example here. Procedure is called identifier 1, which then calls identifier 2. That executes its instructions, and then the code would jump back up to here where more instructions can be executed. Of course, all procedures need an end procedure, or in the case of VB.NET, an end sub command to make sure that particular block of code is finished. Before we look at functions, another important part of subroutines is something called parameters. Now we're going to define parameters, then we're going to look at an example. Sometimes a procedure will need data passing into it so it knows what to do. When a procedure is defined, a special type of variable is declared which receives data from whereabouts the procedure is actually called from. This variable is defined in brackets after the identifier of the procedure is defined. This type of variable is called a parameter, also known as an argument. When the main program calls a procedure, the required data is passed into the procedure, and this is known as passing parameters. So, here we've got our main program called identifier 1. It is calling a procedure called identifier 2, but then in brackets afterwards it's going to pass in some data, whatever that may be. So control passes to the other procedure, which receives the parameter from the first procedure and then uses it in its instructions to be executed. Then of course when this procedure ends, control returns over to here and the main program can continue. So let's think about an example. If we look back at the procedure that disabled the controls on the form, well, I'm going to make this a bit more sophisticated now by using parameters. I'm actually going to call the procedure something different. Its identifier is going to be called enable or disable controls, and I'm going to specify my parameter here. And I'm going to call the parameter B, which is short for Boolean, enable or disable as Boolean, and Boolean is either true or false. It's a data type that allows true or false. And then every time on the resulting lines, we're going to use that value of that parameter that's passed in. I'm just copying and pasting here to decide whether things should be enabled or disabled. When we call up the name of the procedure, the identifier, I've got to specify the parameter that I want. First of all, I'm going to say false. Enable or disable controls false. And that will disable everything. And then later on I might want to re-enable everything, in which case I'd put true. So let's see this work now. Just going to put the breakpoint on there and run it. Here it comes. So if when I click on save, the code stops here. I'm passing in false into my procedure, which is down here. So F8, and the code jumps into the procedure, and the procedure is receiving false. Therefore, txt name.enabled equals false. So it should disable all of the items on the form. Let's go and see if we can see that. We maybe can't at the moment in runtime, or can we? No, we can't see that happening in runtime. But when control returns to the main program, this time I'm passing in true, so everything would become re-enabled. So I've built a reasonably sophisticated sub-procedure here that accepts a parameter and enables or disables controls depending on what I pass in to it. Thinking about it, a better name for the procedure would have been just enable controls. So if I change that in all three places, I think that makes better reading, because we're saying enable controls false, meaning we're disabling them. Enable controls true, meaning we are enabling them. So that's parameters. So what are functions then? These are very similar to procedures. They need identifiers like procedures do. They're called from the main program just like procedures, and they can use parameters just like procedures. The main difference is that functions will return a value to the main program, so the main program can use that value that the function comes up with. So let's look at an example. Simple form with one button on there. The button retrieves a value from the user first of all, which is somebody's name entered into an input box, and then we display something in a message box, and that something actually is the calling of a function, passing in the name that we got off the user. Our function is called sfix apostrophe. This was a common problem from when I worked in industry. If you entered a name such as O'Neill tried to enter that name into a database, it would throw up an error because of the apostrophe. So you'd fix the apostrophe by putting two apostrophes there. It's just how it worked. So the function is declared here, and things to notice: we're declaring a function instead of a sub, and it is using a parameter, and it's passing sname into the sstring parameter here. Sstring is then worked upon, and you don't need to know what this code does at the moment, or we'll look at how to do this sort of thing in a future video, but it does some string manipulation to basically add an extra apostrophe into the name. So as part of the selection process in here, it basically says the name of the function is set to something. So let's see how this works. If we just put a breakpoint on and run it, if we click on go, code stops there, F8 to start to break into it, enter a name. I'm going to just put O'Neill, just with one apostrophe in there, and say OK. So this is where the program calls the function basically and passes in O'Neill as the parameter. So F8, the code jumps down to here. We can see that O'Neill is passed in as the parameter, and then this code basically loops around checking every character. So we've only got as far as the O really at the moment. So what I'm going to do is just put a breakpoint on end function and F5 it, so it's jumped all the way down there. But basically that code will return the value of O'Neill, but with two apostrophes in there. So we've come to the end of the function. If we F8 again, it's going to take us back up to where the message box is going to fire, and then because it's returned the value into this bit here, we will see the result in the message box, and there it is, O'Neill with two apostrophes. So function's done a good job for us there. So let's just define function. Similar to a procedure, defined with an identifier, contains instructions to be executed, may have parameters. Is called from the main program using the function identifier. When called, the main program pauses whilst control is passed to the function. When the function finishes, control returns to the main program. But here's the major difference, is that a function returns a value to the main program, so the main program can use the value, like we did in our message box. So here's a procedure called identifier1, calling the function identifier2, and passing in a parameter. Here's the function called identifier2. It does its job, but it returns a value back to the procedure. So that's how functions work. Just want to talk quickly about something called built-in functions. Most programming languages and IDEs, integrated development environments, will have built-in functions, and they are, again, pieces of code that will do jobs for us and return a value. but they tend to be pieces of code within the IDE that we don't actually see. We call them, but we don't see the code because they're built-in functions to the IDE and they're used by programmers all over the world. So here are some examples. The format function might format text into a particular format for us. The RND function might return a random number, and as with any functions, you pass in parameters. So on the RND function, you probably pass in a start number and an end number, and it will return a random number between the start and the end number. These three here are string manipulation built-in functions, and we've seen the mid dollar one earlier on in the video. It helps to chop up text and return pieces of text from a longer string. The lcase function will put text into lowercase. The ucase function will put text into uppercase. We're going to have a quick look at the isNumeric function. So I've got a little application here that has one text box and a button, and the code behind the button uses the isNumeric built-in function to check the text entered into the box to see if it is numeric or not. But like I say, we can't actually see the code that does that check because it is built in. So if I run that, if I put in 8 and run the check, it says great, you entered a number. But if I put in the word 8, as in I ate apple, it says boo, you didn't enter a number. So that's the use of a built-in function.